Hey guys, welcome to my channel. My name is Lokesh. So as you all know, the Databricks Summit is going on. That's an annual Databricks kind of a workshop where they introduce new features, new tools, new enhancements in the Databricks world. So since we are not able to attend that live, so hopefully someday we will be able to do that, or maybe I will try uh, if I can sponsor that myself, or if there is a company that could sponsor me. So we will try. So the aim would be to maybe one day be able to do that. But nevertheless, let's maybe watch one of the videos where they have introduced something called Lakebase, which is OLTP database. It's like an interesting feature. So let's watch that video.
To talk more about this and what we've been doing at Databricks for the last 2 years to work on the Lakebase, I want to welcome my co-founder, Reynold Shane, to the stage.
Thank you, Ali. We're actually supposed to shake hands, but given you walk all the way there, and I'm supposed to come here, I think it will be a little bit difficult. So virtual handshake. um, as Ali said, Databricks in the last decade has mostly been focusing on the analytics side of data infrastructure. And if you look at analytics systems today, what you use on Databricks, or even on other vendors, they look remarkably different from what they were in the 90s. There's a lot of foundational technologies been invented. Columnar storage, vectorized processing have dramatically speed up analytical workloads. Streaming was invented about maybe over a decade ago, actually can make data a lot fresher. And of course, in 2020, 5 years ago, we published the Lakehouse blog and pioneered new architecture.
So this will be interesting. So let's ask. Streaming. But I think I should be asking for invented streaming databases. Those. Not clearly written that it was invented in 2010. So I think it says that it is a continuous effort of the entire industry, entire community starting from 1990s. There were some people who were doing some sort of work maybe from mid 2000s to present. But there's no clear and precise answer, so that's okay. Let's go a video.
Which decouple storage and compute, and more importantly, based on open formats. And that have enabled a lot of new workloads, dramatically lower the TCO for all the analytical systems. Now, OLTP databases, however, are kind of stuck in the past. What do we mean by that? If you look at OLTP databases running today, whether it's commercial, so proprietary systems like Oracle, or open source databases like MySQL, Postgres, they look more or less the same as they were in the 90s. Yes, we've added a lot of features, they have gotten faster, but if you look at the components and the techniques and foundational ideas, they're more or less the same. Ali even sort of referred it all the way to the 70s of the System R papers. And databases are viewed as this heavyweight infrastructure, requires a lot of manual intervention and maintenance, and it's quite clunky. First, databases are very slow, so the provision, and it's sort of difficult to scale. If your workloads are fairly dynamic, it's often a nightmare to actually deal with that in the database side. And because of that, databases are fairly disconnected from modern day developer workflows. which we'll zoom into it a little bit. And it's also very silo from analytics and AI. Like it's actually not unusual these days. You want to combine analytics and AI with your transactional database workloads, but it's very difficult to do. So what did I mean by databases that disconnected from modern day developer workflows? Well, imagine you're a software engineer and you're trying to add a new feature to a code base. The very first thing you'll likely do is the following command, git checkout -b, maybe click in the UI. But what it does, it creates a new branch of your code base. And you make changes to this new code branch, adding new feature, maybe fixing a bug, you'll be testing against it. But all the changes you do are isolated to this specific branch. And creating a new branch is an instant operation. It's very, very fast. You don't have to think twice about it. You just do it, right? What's the equivalent for databases? You want to clone your production databases? It might take days. You put one up, you almost never shut it down. Some things like this simply doesn't exist. Like, wouldn't it be nice if you can branch off a database, just like you would do with code? Now, let's say you get past all that development hassle and you manage to build a pretty successful app, which many of you have. And now the app has taken off. You want to introduce some analytics capabilities or AI capabilities to the app. So you have your app development team now start talking to your data infrastructure teams. They're managing the lakehouse. You say, hey, how do I actually get the data from one side to another? Now you have to figure out how do you manage two disparate systems. You have to understand the IAM role differences. How do you set up secure networking? How do you create ETL pipelines and load data from one to another? You learn fancy terms like change data capture, STD type 1, STD type 2, which I, up until this stage, still don't understand what they are. It just seemed awfully complicated. So in the past couple of years at Databricks, we've been working on how to tackle this problem and actually eliminate all of the challenges. And the result of that is Lakebase, right? Lakebase has the following attributes. First and foremost, it's based on open source Postgres. And second, it built on a novel decoupled storage from compute architecture that actually enables the modern day developer workflow. And by building on top of Databricks infrastructure, it comes with what you would expect, actually amazing lakehouse integration.
I think there is an important uh, terminology that the author used
And
here.
by building on top of Databricks infrastructure, it comes with what you would expect, actually amazing lakehouse integration as well as all the enterprise readiness features. Now, let's talk about them one-on-one. So, and second, it built on a novel decoupled storage from compute architecture that actually
Maybe let me turn on the subtitles.
following attributes. First and foremost, it's based on open source Postgres. And second, it built on a novel decoupled storage from compute architecture that
Novel decoupled storage from compute architecture. So it's a new architecture. So we already know that compute and storage can be decoupled, but why he's calling it as novel? Yes, novel decoupled storage. So I think even here you can see that decoupling storage and compute is not new. But what is novel? Novel aspect The primary challenge with decoupling is the increased network latency when data has to travel. Okay. Novel approaches focus on high-speed loads using technologies like RDMA, smart caching, and increasing data locality, optimizing data format using column storage, okay, auto scaling time, cost optimization. So this is an important um, can place it on what at this. So this will be useful. So let me just send it across to myself. So guys, you can also do the same thing. So usually, what I do is I try to put this up on LinkedIn. So maybe I do the same thing here. And it's not only about sharing it for your audience. So maybe you can use the LinkedIn space, to share it with just as a just as a way of pinning something, so that you can refer it later. So that's why we are doing it. So post it. Now let's come back to the video.
Actually enables the modern day developer workflow. And by building on top of Databricks infrastructure, it comes with what you would expect, actually amazing lakehouse integration as well as all the enterprise readiness features. Now, let's talk about them one on one, so one each after each. So first and foremost, Lakebase is building on open source standards, which is open source Postgres. And in the last few years, open source Postgres has steady on the rise. And if you look at the latest Stack Overflow survey of the most popular databases, Postgres actually leads by a wide margin. And this is because its robust ecosystem of tools, libraries, and extensions, and all of this just work out of the box on the Lakebase. And Lakebase can guarantee you single-digit millisecond latency at scale. The second most important part to Lakebase is building on a new novel separation of storage from compute architecture. And it actually has 3 layers to this architecture. At the very bottom, we're using data lakes or object stores to store the actual physical data. And object stores are the cheapest storage medium you can find. They're extremely reliable at scale. Now, one of the challenges that Ali actually referred to is that object stores were not exactly designed for the type of workloads that OLTP databases need. 100 millisecond query is plenty fast in the lakehouse for analytics, but 100 milliseconds is actually unacceptable for OLTP workloads. We need single-digit millisecond latency. So the way we've solved that is by introducing a middle layer storage that's actually only have soft state, and it acts as a write-through cache for all the data to the object stores. And for some of you that are database nerds, it also creates a new way to very quickly persist the write-ahead log, or what we typically call as WAL, in the database. And on top of the storage layer, we have the ephemeral compute nodes, which are Postgres instances that actually reads and writes to the underlying storage layer. One thing that's very important for me to point out is very similar to lakehouses. The actual data that's stored in the object stores, the data lakes, are open source formats. They are not some proprietary format we invented to actually improve performance or to lock you in. They are just vanilla Postgres pages. And this opens up a whole new sort of paradigm of opportunities. And there's actually a lot of past attempts at this problem. This is not the first time I think sort of the industry have tried to create separation of storage from compute architecture for OLTP databases. Some commercial systems, especially from hyperscalers, have done that. But they were typically actually built on yet another proprietary storage system. They are way more expensive and also don't use open source formats, which means they can manage to lock you in even more so. The way we crack the code here it's actually based on, some of you might recognize the architectural diagram. Say, hey, didn't Databricks actually acquire this company called Neon just last month? And you're already talking to us about it. No, we did acquire Neon. We announced acquisition last month. We actually only closed the acquisition last week. But one of the interesting things that's not widely known is we actually invested in Neon, the company, many, many years ago, and been working with Neon team as a technology partner on this separation of storage from compute architecture. And everything on Lakebase is actually building on this collaboration. Right? And building on top of this new novel architecture, we managed to accomplish a few fairly interesting things. The first is serverless. And what do we mean by serverless? Well, earlier we said databases are this heavyweight infrastructure that requires a lot of manual maintenance and intervention. Serverless here means database should become lightweight. What does it mean that it's lightweight? Well, Lakebase come in two flavors. The first flavor is a provision throughput flavor that it shows you actually specify exactly how big you want it to be. If you know.
One of the other questions that are coming to my mind is usually when you have the storage and compute separated as it is in Synapse or for that matter, Databricks, data tables as well. That's mostly in distributed systems. So does it mean we have storage and compute separated in non-distributed systems? Like there would be a single node for storage and maybe single node for storage and multiple for compute. So that has to be seen. Another important feature that I think Renard, talked about here is uh, the ability to branch the data. Branch the data using Git. Like,
Know how to size your world, that's the perfect sort of, solution for you. But for most people, the auto-scaling flavor will be far more interesting. In the auto-scaling flavor, you don't have to worry about how big a database you should be picking. And because the databases are actually just ephemeral instances, you could only launch it when you need to. It takes less than a second to launch a brand new database. And if you're sort of low scale, you could either vertically scale it, which the system will do it for you, or you could choose to create read replicas that also comes up in less than a second. And if your load goes down, and you actually no longer have need, for example, say for a very American-centric company, past 5 p.m., maybe you have no loads, you can actually automatically shut it down very quickly. All of those just happens in less than a second. Right? And the best part is you only pay for when the duration you actually need the compute. The second thing we built was branching. We talked about earlier how difficult it is to branch off a database and to apply modern development software practices to actual databases. It's very easy to do it with code, but it's very difficult to do with databases. The separation of storage from compute architecture also has a copy on write capability built in that we can instantly branch off a database. It takes less than a second to create a whole clone of the database. And that includes both the data and the schema of the database. And because of the copy on write capability, you don't actually have to pay for extra storage unless you start making changes. And only the changes themselves will incur extra charge. Because under the hood, they all share the same storage. So something pretty magical would actually happen when you combine the branching capabilities and the serverless capabilities into one. It would completely change the way you think about database development. Every time you do git checkout -b, you should automatically actually branch off a database with that new branch of code. You should have them perfectly in sync, making schema changes. If you actually don't like your new code branch, And whatever changes that make to the database, it's just kill both the code branch and the database. You pay next to nothing, just like how you're paying for your code repository. Right? And this is extra important in the age of agentic coding and AI. With AI, like one way to think about AI agents is you're getting at very low cost an armies of thousands, or maybe even in the extreme case, millions of AI agents. And the AI agents are acting as their own individual engineers. They're doing experiments on your code base, maybe adding new features. You might even have multiple AI agents adding new features, adding the same feature, and you have judges to determine which feature is the best implemented. And it's now every AI agent can actually get their own code branch, but also their own databases at virtually no cost for experimentation. The separation of storage and compute, especially by leveraging actually open source formats underlying storage layer, also makes it super easy to synchronize data at very high throughput from one object store to another object store. So from one data lake to another data lake, from Lakehouse to Lakebase. And many of you, if you're an existing Databricks customer, given what we're doing, you probably actually expect this out of the box. You can publish any tables in the Lakehouse into Lakebase for real-time serving to get your 10 millisecond latency. And you can also do the reverse. You can very easily get the data from Lakebase directly into the Lakehouse, managed by UC Unity Catalog with a few clicks. And of course, by building on top of Databricks infrastructure, Lakebases are sort of enterprise ready. It comes with all the bells and whistles you expect, from security to compliance to governance. So, given Lakebase, what can you do differently? Well, first, if you're trying to build a new app and you need a relational database, give Lakebase a try. If you want to serve data, you have data today, whether it's machine learning, feature stores, or whether it's simple data pipelines to build, you want to serve that data, give Lakebase a try. And if you have ETL pipelines, complex ETL pipelines that ingest data from a relational database into Databricks, which I know almost every customer does, give Lakebase a try. It'll dramatically simplify your architecture. So with that, I would like to invite Holly Smith onto stage to actually give you a demo to visualize what it looks about. And I think Holly's actually going to come up on that side. So you have slowly shifting the stage.
Hello. I've been given the job to manage inventory levels for a drinks company, making any last-minute adjustments to stock, but also to share data between apps.
So another thing, guys, that I was very funny. Object storage. Just review this. The object storage is, mostly how you store your data in ADLS. So I think when you create an external external data table, so that is also a form of object storage. So which means that I would question whether it will be on distributed or not. I think that is answered. Data will still be distributed. Uh, based on you know what sort of storage you're using. Because ADLS by default does that for you. It's a distributed system, right? So data will still be distributed. So only thing, then the question is why we are relatively so because can shift very faster. Just for the reasons. So straight after the video.
Analytics teams. This job is tricky at crunch time, but fortunately, I have some new tools from Databricks to help me. And today, I'll be sharing how Lakebase powers Databricks apps, works at scale, and can use data from Delta tables, all in real time, all in one platform. So I'm going to switch to my demo, and in front of me I have a Databricks app that's bringing together both operational and analytical data. Whenever I'm changing these filters, these are live queries. Nothing is cached in the app. I can see here orders that I need to review, but I am not going to do that. Instead, I am getting some intense requests to place some orders for Cherry Burst for 90 units. I'm going to select my store, click through the app, and go. This app will go and update Postgres in the back end where the orders table sits. Now, I'm going to double check that this has gone through correctly, and I'm switching to the brand new Postgres SQL editor natively integrated to the Databricks platform. And I can tell it's Postgres because I've got this icon on the top right here, and when I select my compute, it's got this Postgres tag next to it. I'm also not going to do this on production, so I am going to use dev, which is an isolated test branch. And if I look at the left, I can see some neon details. I'm also going to check the settings of the version, and I can see that, yes, this is Postgres version 16.6. And to query the data, I would just query it like I would any other table. And I can see here that when I run this, that yes, my order has gone through. But that's just one record, and that's not very impressive. So earlier today, I set up a little program to simulate lots of users to run in the background. I'm going to switch to the native performance monitoring in Databricks. I'm going to head to this metrics tab here, and I can see how this has ramped up to thousands of transactions a second and tens of thousands of rows per second, and I've got all sorts of interesting operation types happening here. One thing this doesn't have is our app latency as it scales. And fortunately, I bought my little program so that it can measure latency. So I'm just going to run a simulation and see how well we're doing. And, oh, I can see my performance is almost 19,000 queries a second, with the median at 4.56 milliseconds and the 95th percentile at 5.6 milliseconds. So I'm pretty pleased with that. Thank you. Lakebase can also access data in Delta, and I can combine them together for snappier responses in the UI. So I head to the table in a Unity catalog, I can create a synced table, I go ahead and I can name the table, I select which instance I want to use production, I can also choose the database as well, and then the primary key. Now I can either run this as a one-off snapshot, triggered at a certain interval, or have it continuously updating. And I can either group this with other updating items in a pipeline, or I can have it as a standalone. Now that that's set up, when I go to it in Unity Catalog from the database view, I can see here that I've got this little synced icon next to my table. And so now when I head back to my app, oh, here it is, and I head to my Insights tab, I've got this Insights tab, and that is including data from a Delta table for my forecast. And of course, I can sync all of my orders data back to the Lakehouse for historical analysis and the other way around too. So in this demo, we've shown how Databricks is bringing together both operational and analytical data closer together. And I hope I've shown you how powerful this is when combined with other Databricks features like apps, Delta, and Unity Catalog. And it's inspired you to give it a go on your next project. And as for me, I don't think I like being an inventory manager, and I probably should have made this an agent. Back to you, Reynolds.
Thank you, Holly. And Tony, Virtual handshake. So at Data and AI Summit and other conferences, we announce products of various stages of maturity. Where is Lakebase? We just spent so much time talking to you about it. So in the last year, we actually been private previewing Lakebase with hundreds of customers, and many of some of their logos actually showing on the stage here, across a very variety of industries. Many of them actually running Lakebase in production. And we're also very happy to have the following launch partners joining us to announce Lakebase itself. And this includes of catalog vendors, BI vendors, agentic coding platforms, and consulting services. But the best part is that Lakebase is available today. All right. Woo! So not something coming next year, but today. Starting today, in all of your Databricks workspaces, depending on which region you are, you can either explicit opt-in or it's already on out of the box for you. It includes the full-blown, fully managed Postgres instance, all the Lakehouse integrations, multi-cloud support, HADR. All right, and there's a lot more new features coming in the coming months. So just to summarize, Lakebase offers a fully managed Postgres instance. It comes with a new novel separation of storage from compute architecture, which enables the modern-day developer experience, both for humans and for AI agents. And more importantly than the Lakebase product announcement, we actually feel like this is how database should be built in the future. And our prediction is every other database, every other transactional OLTP database will evolve towards this architecture in the coming years.